Alright, so today we're going back to coordinate geometry and we're looking at circles. So a quick recap. Okay, so we need the midpoint, 2 points, which again is the average of the 2 points, x and y's, and length of line, which is the difference in y squared plus the difference in x squared, all square rooted. So, quickly trying to summarise a circle using those two ideas. So all a circle is a line that connects points that are all the same distance from a central point. So if you imagine there's a centre, a circle is the line that connects all the points that are the same distance from the middle, and that distance we call the radius. So if we have a centre of AB, all of the x and y coordinates on this line should have a length of r away from AB. So if we put all of that together, we can say the radius is a square root of the difference of x minus a, so the length between any x coordinate, be it here or over here, x minus a squared plus y minus b squared, so the difference in the y's from here to midpoint, should be the length of the radius. And what we normally do for circles is we get rid of this square root and we put it there instead. So that is the equation of a circle. Okay, so where r is the radius and AB is the centre. Remember, if positive A, positive B is the centre, we have minus A, minus B in the brackets. It's always different when you're inside our function. Okay, so for a really basic circle that has its centre on the origin, so a circle like that, you get r squared equals a squared, r squared equals x squared plus y squared, because a and b are 0, so the equation gets a bit more simple. Alright, so if we get given 2 points and we're told that they're the diameter, we can easily find the equation of that circle. So given 2 points, we want to find the equation of the circle that has that line segment as its diameter. Well, if that's the diameter, the midpoint of AB will be the coordinates of the centre of the circle. So we use our midpoint equation. Remember, it's the average of x, comma the average of y's. So we get 1, 5. So I know the centre of our circle is going to be at 1, 5. Sorry, that should be minus 1, 5. So there's our centre. The only other thing we need now is the radius of the circle. So if we find the length of AB and half it, that will be radius. So we end up with this equation, so we get root 4 plus 36, so root 40. And root 40 we can say is 2 root 10, so that's our diameter. So half that we get our radius, so root 10 equals the radius. And once we've got our midpoint and our radius, we can just put those into the circle equation. So we get x plus 1 squared plus y minus 5 squared equals the radius squared. That's going to be 10. So that is the equation of that circle. Just be careful with these. Remember, when you're finding the length of AB, you're actually finding the diameter, so remember to half it. Then it's the radius squared that goes there. The other thing you could do is find the length between A and the centre, which would be the radius, and then you don't have to worry about that. But always sketch it so you're sure of exactly what length you're finding. Okay, let's try another example where instead of knowing those 2 points, we know those 2 points. Right, so we can also find the equation of a circle if we know the centre and one other point. I'm told the point 42 lies on the circle, so that's point A in our picture here. and then we're told the centre is A1, so that'll be our centre here. So there's two bits of this question. Part 1, find the equation of the circle. Part 2, show that 3, 1 lies on the circle. So if you guys want to pause it and give this a go based on what we've done already, go for it, but I will go through it in a second. Alright, so first bit, find the equation of the circle. So this time we need to calculate what the radius is. We know these 2 points, so we need the radius. So length of line equation again. So we need to use our length of line equation again, so that's already here. So working through that. So we get our length is 5. So our radius is going to be 5. And we've got the radius, we already know the centre, so we can put it all into the equation of the circle. So we get x minus 8 squared plus y minus 1 squared equals the radius squared, so 25. Okay, part B, show that 3, 1 lies on the circle. All we're going to do is put in the point 3 is x, point 1 is y, and see if it does equal 25. So we get 1 minus 3 minus 8 squared plus 1 minus 1 squared equals 25. 3 minus 8 minus 5. 1 minus 1 is 0, so it's minus 5 squared equals 25. Yes, so point minus 1. Circle. Excellent. Alright, next bit, we're going to do some completing the square on circles. So circles won't always look in this neat form. Sometimes they'll be expanded and we're going to have to refactorise to find out what the centre and the radius are. So if you expand it, you might get something like x squared plus y squared, 2 a function of x plus 2 a function of y plus c, something like that. If your circle looks like that, you first have to complete the square on the x's and on the y's to get it back into that nice bracketed form where you can find the centre and the radius. So we're going to complete the square twice on this to try and sort it out. So there's our circle. What we're going to do is collect terms. So we're going to get all the x's on one side, all the y's on the other side, and then try and complete the square on it. So x's, y's, numbers over here. Now we're going to complete the square on this part. So there we go, complete the square there. Now we'll complete the square on this part. And then we're going to just add these 2 onto the other side. Adding those over, we get x minus 7 squared plus y plus 8 squared equals 125. So that tells me that this circle has a centre of 7 minus 8 and a radius of 5 root 5. Cool. So we can also do the kind of general corner geometry kind of questions with circles as well. So for example, find where this line intersects the circle x squared plus y minus 2 squared equals 29. So just like we did in standard corner geometry, we're going to solve simultaneously to find out where those 2 lines intersect. So I think the easiest way is to substitute y into y there. So I'll end up with an x quadratic. So you end up with that, and we can then factorise that one. So find AC minus 40, B equals 6. We need factors of minus 40 that times the next 6. Or we can actually divide that by 2, which would be a bit easier. So divide that by 2, x squared plus 3x minus 10 equals 0. So it's going to be 5 and minus 2. So x equals 2, x is minus 5. We need some y coordinates too, so let's just put these back into the line. So y equals x plus 5, so y equals 7, and y equals 0. So we get 2, 7, and minus 5, 0. Cool, right, last problem, we're going to try and combine the circles with a discriminant problem. So looking at number of roots and solutions. This is more advanced kind of circles question. Alright, says the question, show that the line does not meet the circle. So, if we were trying to find where it met the circle, we'd solve them simultaneously. And you can think ahead, if we put x minus 7 in there as y squared, we'd end up with an x quadratic. Now, if it's not going to meet the circle, what it means is that that quadratic will not have any solutions. In other words, the discriminant to that quadratic will be negative. So, there's our two steps. So, step 1 is going to be solved simultaneously, and step 2, show that the resulting quadratic has no solutions. So, if we solve those simultaneously, so I've substituted x minus 7 into y and squared it. If we expand all of that, we get that lovely long quadratic there, and simplifying that we get we can half that, and now we need to show this has no solutions. So we're going to use the discriminant. Remember we got a, b, c, so b squared minus 4ac. And if it has no solutions, this should be less than 0. So b squared is minus 5 squared, minus 4 lots of a, which is 1, times c, which is 10. So we get 25 minus 40, which is going to be negative. 25 say 40 is minus 15. So b squared minus 4ac is less than 0, therefore no solutions. Therefore, the line does not meet the circle. Cool. Right, any problems with that, either email me or watch the video again. That's one of the more difficult problems because we're trying to prove things don't meet and mix together circles and discriminants. Alright, on to quiz, and that's the end for this week.